Alright, so I want to go over the homework first. We're going to do more review today for random numbers and for loops. I have some more exercises for you guys to do, just with the hopes that we'll get more comfortable writing this stuff. And then we'll go over some new things today, which are, we're going to be going over arrays and a concept in C++ called objects. So we'll talk about that today too, after we do this homework. All right, so I asked you to do two things, a dice rolling program that rolls 20-sided dice only, and then add up the results of all these dice rolls and output it to the console, and you must use a for loop. In addition, I asked you to write the implementation for the factorial calculation of a number, and you also must use a for loop there. So let's do both of these. Okay. So the first program is I want you to roll some dice that are 20-sided. So again, I want to reiterate kind of what I went over last week, which was that how to actually start approaching a problem like this and breaking down a problem into like the smallest pieces that you can do. So for number one, for instance, a dice rolling program, and like there are two main parts to this. One is the dice rolling part, and the other one is adding up the results part. And you can pick whichever one to kind of do first, but I recommend doing one of these first. And in this case, I think the simplest thing is to just start with, hey, let's do the dice, and let's just start with even just simpler than that. Let's just roll some random numbers, right? Like, even if you don't know where to start, you know that a dice is going to need some kind of random numbers. So getting that working first, I think, is a good starting point for where you should start with your homework. And my recommendation to you was that whole seeding the random number part, I said you kind of just have to take that and use it and remember it and use it in your future projects. It's also in the book. But remember, you have to call srand, and srand taking a number is the other important part. In addition, when you're using srand, there's a couple libraries you have to include. Particularly, you have to include the C standard library and C time, because this lets you seed the randomizer with time, and this includes the randomizer functions. So you could put like 14 here, but remember you want to pass in time. And when you're passing in time here, normally it complains that when you're passing in time, you get this warning saying conversion from time t to unsigned int. So you can just get rid of that by doing a static cast for unsigned int around this guy here. This whole line is something I just want you to do and just copy and move around and use over and over again. The next thing I would probably do is just output a random number. And that's it. Like I would just output the result of a random number here. You can put this in a variable. Rand, and then C out here. And this is a good starting point. It isn't much, but it will let you see that a random number is properly getting generated and that your program runs and compiles correctly. I think that's a really important part too, because sometimes you get into situations where even this isn't really working correctly, and you kind of need to like diagnose and fix that before you move forward. So I see that it's 23,000, 23,507. It is changing every time. Because a randomizer is seeded based on time, you see that the number is going up kind of sequentially. So here's our dice roll. The next thing is I want to get a dice roll that actually rolls a number between 1 and 20. Right now this thing is giving me really big numbers, but if I take this in modulo 20 and add 1 to it, our dice roll here will now be between 1 and 20 as a result. There's 20. I got 10 there, and 19, and 6. All right, so I think the first part of this is rolling 20-sided dice. This is basically all you need, which is to do the random generation and roll a 20-sided dice. The other part is that I wanted to write a loop that adds up the results of all these dice rolls and outputs to the console based on how many dice they want to roll. I think the first thing I want to do is just have a loop that just loops forever, right? Now, normally what I would do is do this. I would do a while true around the parts that I want to see looping forever, because I want to see it able to do all this random number generation. And so I can prove that it's generating random numbers in a loop. I just need to control how many times it does this, and I need to do this using a for loop. So I've wrapped the parts that I care about here into a while loop. So I'm just going to replace this while loop with a for, and I'm going to start writing the 3 parts. Remember that there's 3 parts to a for loop. There's the initialization, there's the test expression, and there's the increment, or we call it the update expression. So these 3 parts here, which I put in comments in between the semicolons, indicate the 3 different parts of a for loop that we have to write. I'm going to talk too, like you can actually leave some of these out if you want to. However, the number of semicolons here has to always remain the same. I'll talk about that in just a second. But first, initialization here, like you need to create a variable that counts up how many dice you want to roll. Typically what you do is you make a variable, you give it a name, and you initialize it to 0. That's like the most common thing you do inside of a for loop, right? Another thing that's really common in for loops is your variable that you use to indicate the counter is typically something simple. Like we use I most of the time because I stands typically for like index, and it's also something you write for loops so often that you want to try to keep this simple. This is one of the only cases where having a single letter variable name is really universally kind of accepted, because for loops are so common and it's so easy to understand what they do that this right here is okay, even though the variable name is so short. The next thing I want to do is write the test expression. I want to do this as long as the I is less than 10. I'm picking a number here that just I typed in. I haven't asked the player for a number yet. I'm just typing it in here because I want to see it loop 10 times. I just want to write a loop and have it be hard-coded to be 10 times. And then my update expression is I++. Because I want to add 1 to this variable every time I go through this loop so that eventually my I variable will hit the number 10 and then I can break out of this loop because this will no longer be true. So now when I'm running this, I should see 10 dice rolls show up on the right side. 10. So I've gotten the second part kind of working, sorry, the second part of this, which is I want to roll that many dice. However, I haven't actually asked the player for it, so let's do that now. I'm going to create a variable called numDice. It's going to be equal to 0 by default, meaning that if the player types in nothing, that I'll at least have this variable be initialized. I'm going to ask for how many dice do you want to roll? And I'm going to put that number into this variable here. So now this variable stores how many dice I want to roll. I'm just going to replace this 10 here with the number of dice variable. So now what I've typed in here gets used here inside the for loop. It's no longer just 10. I've actually used what the player has typed in. Any questions on this stuff so far? So if I want to roll 5 dice, I get to roll 5 times. If I want to roll 1 dice, it still works. What happens when I roll 0? Nothing happens. That for loop never actually even does a single dice roll. Same with -1 and 100. I roll 100 dice. All right, questions on this? Okay, so let's do the next part, which is to add up the results of all these dice rolls and output it to the console. So I need to add up this dice roll into something that's keeping track of how many I've had so far. So I need to create a variable that I can print out here. So there's a couple places you can put this. I'm going to create a variable called sum. It's going to, again, start at 0. And I'm just going to take my dice roll, like so, and I'm going to add it into the sum, like this. Remember that this is the long form of this, plus equals. Just by doing this plus equals, I can add it into the sum. And then finally I can say like that. And I can print out the result of all the dice rolls. So this is me rolling 10 dice, and the result of all the dice rolls is 120. All right. Questions? Oh, sorry. So, kind of an interesting thing is, how would I set it up so that instead of printing out each dice roll on a separate line like this, that I set it up to look like an expression, kind of like if I wanted the output to look like this. Whatever this is, 32, 37 plus 5, 42. So I want to show you guys how you can also print out this, because I think printing out this is also kind of a neat part of this, like having it print out this result. Instead of just printing out each number on a separate line like this, I think it'd be nice to actually show all these dice rolls like with the plus sign in between. Did anyone actually try to do that at all? I can try to do a little bit. I'm just going to show you that because it allows you to like demonstrate that it's not just a matter of using for loops to add things up, but you can also use it to format strings. But we can start with something simple here. If I'm already printing out the number here, what if I just didn't do this part here? And I just ran that program like that. I get all my numbers in a single line, right? If I did the same thing here and replace this with equals, at the very last thing that I do, I get something equals 102. So now I just have to figure out a way to inject pluses in between each one of those things. So I could just start with this, like so. Literally just putting the string plus in between those, and then running this. And I get almost what I want. I get 1 plus 14 plus 2 plus 18. But I get this last bit here, which is a little plus, a dangling plus. How do I get rid of this guy here? Why is this guy even printing?
Because that's how the loop is running.
Yeah, so like the loop runs and prints out 15 because that's the last number it generated. And it always is being told to print out the plus sign. How do I stop this specific plus sign from running? It's kind of an interesting problem because this, the stuff that prints out the plus, is inside the loop. So I can't just like move this somewhere. I actually have to have it in a loop. The key here is that you need to change when you print this part out. So there are a lot of ways you can do this, and I'm going to show you 3 different ways to do this very thing. And they're all in varying ways of like good or bad, but I just want to show you all 3, and they're all valid. So what I can do, the first initial way is I can say, hey, let's make an if statement that says if I is less than num dice minus 1. Look at what my if statement is here. It's the same exact thing as the for loop, just I'm subtracting 1 from it. I'm saying, hey, as long as you're not the very last time through the loop, you can print this out. So as long as you're not the last one in the loop, go ahead and print out your plus sign, which means this will be true for every number except for the last one. So this is one way you can actually have it skip the plus sign at the end, because the last time through the loop, this statement will be false, which means it'll skip over that. Okay. So here's another way you can do this. This condition here, you can change it so you can use a variable instead of just printing this out like this. Here's another way you can solve this. You can have a string, which is the I'm going to call it the suffix. I'm going to include string. The reason why I do this is I'm going to make a variable that stores what I want to add to the end. And instead of doing cout, I can just say suffix is equal to an empty string here. And then here, I can just add the suffix onto the end. And this is kind of like a little bit more wordy, but you get the same result because you have a variable that controls the suffix. The reason why you'd ever want to use this, oops, I have it reversed here. The reason why you'd ever want to use this is if you ever want to do more than just plus. Like let's say you have a case where you want to subtract numbers sometimes. You want to change the string in more than just adding a plus sign. You can do it with a variable and you can control what it says. For instance here, maybe I don't want to say plus. Maybe just half the time I want to say minus instead. So you can change a suffix here by creating a variable that stores what you add to the end. You can change what you're actually adding. So in this case here, I can make this thing be, I know exactly what I'm going to make this thing. Where's my... You guys ever use this site for like your meme spam in games? It's perfect. You go to this site and you just like you want to express yourself using emojis. Just like grab one of these guys. I click on this guy here, and you can just stick him in there. I don't know if this is going to work. Kind of works. So if the number is even, it does a little emoji. As a simple example, I could do minus here. It's not really subtracting, but using this method allows you to create something that has more of an expression look. See how I have minus in between each of these things? By using a variable, you can basically change what you're adding using if statements here. All right. The third and final way you can do this is, instead of doing any of this, instead of writing any if statements like that, you can do what's called a ternary operator. Now, a ternary operator is essentially an if statement that's in one single line. Whereas normally when you do something like if I is less than num dice minus 1, and you have an else statement like this. So when I did this originally, I just did cout this if I is less than dice. So if it's not the last item in the list, print this out. Otherwise, print out this. This whole statement, which is looks like 8 lines of code, you can condense into a single line of code. This whole thing can be represented with this operator, which is called the ternary operator. This thing is a question mark. The way this works is you have an expression, question mark, true statement, colon, false statement. That's how this thing works. You put whether it's true or false here, and if this expression is true, you'll run this statement. If this expression is false, you'll run this statement here. And this is essentially a very tiny if-else statement. For instance, normally an if-else statement is this. You have your true statement here, and then you have your false statement here. The ternary operator essentially combines this whole thing into a single line like this. So let me show you what that looks like in usage. So I can write I is less than num dice minus 1, question mark, plus, colon, empty string. This right here says, if this is true, print out this string. If this is false, instead go to the right side of this colon and print out this string instead. This means that I can get rid of this entire if-else statement. Oops, I can delete this whole thing. So now my cout statement looks like that, all in one line. And this allows me to print out plus only when num dice is less than 1. I is less than num dice. Where did I screw up? Let's see here. There we go. The thing that to keep in mind, which I just ran into with ternary, is that the order of operations for this thing is kind of weird. It tries to do, it's really beneficial to you to wrap the whole thing in parentheses, because when you're using stuff like this, the order of operations tend to sometimes get confused whether you want to actually print out this or whether you want to treat this as the statement. So sometimes it says, oh, I'm going here, I want to print out this instead. So it's going to try to print out whatever this is here, which will be 0 or 1 instead. So wrapping this whole thing in parentheses will help. So yeah, those are 3 different ways you can print out the same result, the plus in between each number. And I wanted you guys to see this because we're going to be doing this for practice today. So keep this in mind when you're doing it.
Keep it in my mind.
Yeah, keep it in your mind. All right, any questions on that?
I feel smarter.
What's that?
I feel smarter. With my smarties.
That's good. Write a program that asks the user for a number and outputs a factorial of this number. So a common interview question, which is to write the factorial. And typically what people will ask is write a factorial, and they'll ask you to do it 2 ways. So this is one of the ways it's going to ask you to write the factorial, which is iteratively, which is that is to use a loop. So let's go over how to do this one too. So I'm going to do this one after this one, so I can put this up on Zool so you guys can have it. So writing a program that asks the user for a number and then outputs a factorial of that number using a loop. So it's just the number n times the number n minus 1 times the number n minus that number minus 1. So really just multiplying those things together. You're multiplying every number by each other. So it's a lot like the sum of a number. However, you're multiplying the values instead. So again, I want to start off simple. I want to start off with just asking for a number. So I'm going to say what is the number you want the factorial of? I'm going to create a variable called factorial 0. And I'm going to read into that number here. Then I want to write a for loop that just prints out this number decreasing down to 1. Okay? So if I write a for loop, and I can just do this by hand, and I can write a for loop that counts down from 5 down to 1. I'm not even going to use this thing that I have written right there. I'm just going to print out what I is. Each one on a separate line. I'm going to run the program so that I just print out, I should see the number 54321, and then it should exit after that. Okay, that's what this loop is going to do. So let's get past the dice rolling part, and I want to see the factorial of whatever. Remember, it's not using what I type in. It's just going to print out 54321. I typed in a number that was too big. So see how I have 54321 printed out? So if I can just take these numbers and I can just multiply these numbers by one another and store the result, then I have my factorial. So this is literally just a for loop that just counts from 5, decreases by 1 every time, and stops when it hits 1. So if I create another variable here called result, I set it equal to 1 this time. Because if I set it equal to 0, I'm not going to get the right result because it's going to be multiplying result by 0. It's going to be multiplying these numbers by 0. So all I have to do is take result, multiply equal times I. Because this right here, remember this is the same as me taking result times I. And if I print this out at the end, I should get whatever 5 times 4 times 3 times 2 times 1 is. 5 times 4 times 3 times 2, 120. I should get that as the result at the end. And I'm just typing in, I'm not even using the number that I typed in. But I do get the result of 120. If I change this number to be 6, what is that, 720? So you can see by changing this number, I get a different factorial. So now all I have to do is take this number and just shove it into here. And now I have my loop that loops over, starting at the number that I typed in, counting down, and then multiplying each of those numbers, I, into the result. roll 10 dice. I want to calculate the factorial of 10. That's a really big number.
Try 100.
I don't think it'll actually do 100. Yeah.
0.
Yeah. It actually is undefined. I'm multiplying a number that's that big. If I do unsigned int, I should be able to see some number there. No, still no number. 100 factorial is a gigantically huge number. I don't even know, like, let's do 100 times 99 times 98 times 97 times 96 times 95 times 94. Factorial is an immensely huge number. I don't think I've ever used factorial, like, in game development ever. So again, as I mentioned last week, this is more like an exercise in, like, writing loops more than an exercise in game development, but keep in mind that it is something that exists. We do use it to describe complexity of algorithms. There are, like, whenever you're describing how long it takes to do something, you use what's called a big O notation, which big O notation is kind of a computer science concept which indicates how expensive an algorithm is. It explains, like, as this algorithm reaches the infinity, as it reaches towards infinity, how long, what order of magnitude is this going to take? So we have these things called big O. And so you can see here, this is in order of how long it takes to, like, perform that algorithm for any n number of values. So, like, for instance, big O of 1 means that the time it takes to do that algorithm is the same no matter how many numbers you have. So for instance, I have 200 million people that play League of Legends. Finding one of them should take the same amount of time, no matter if I have 200 million or 200 billion. The amount of time it takes for me to find one of those players is big O of 1, which means it takes constant time. The rest of these kind of increase in order, and these basically indicate that, hey, like in this case, big O of n means as I get more people, the cost of working on those number of people goes up linearly, which means that it's a rate of growth that is constant. In the case of n squared, it means that the more I have, it takes exponentially longer to find that. So for instance, in the League of Legends case, if I had 10 people in League of Legends and I wanted to find one of them, it might take 1 second. If I had 100 people in League of Legends, it might take 1 minute to find one of those people. And the growth of that is not necessarily linear. It's actually something that is more on the quadratic side. Then at the very bottom, here's where you see the factorial. So you can see above all these things, it's increasing order. The very largest big O of n typically that you see is big O of n factorial, which means that the more people, like, it grows so fast that it almost gets to a point where if the problem is a little bit too big, it's almost unsolvable. So, like, it would take such a long time that by the time you finish solving it, like, the universe would explode. So, like, the time it would take to actually figure out the result of that, depending on how many you have. So, yeah, the factorial is only really used in this case for describing how expensive a function is. All right, any other questions on this? So, typically, though, I will show one thing, which is that you often get asked to do this two ways. You get asked to calculate a factorial like this, which is use a loop. The other way that you usually get asked to calculate factorial is by using what are called recursive functions. So if you guys are interested in knowing, like, how typically, like, what people are curious to see if you know, recursive functions is another way that you implement this, which is essentially a way to use functions without using a loop, you can calculate a factorial. Okay? There's a way to do this without using a loop at all, which seems crazy, right? Like, how do you add up the thing? That'd be like adding up a result sum without using a loop. Do you guys want to see how to do that? Maybe? So this is going to get into, like, next week's lecture a little bit, but I am going to show you guys a little bit of how you can do this. And it's going to kind of, like, I just want to show you because I think that this is a really interesting problem where you can basically calculate the factorial of a number just by doing on a single line like this. Let me do this. So you can actually just do this. This is the result. This is the factorial now. So calculate factorial just by calling one function. And this thing here will not do any loops. And that's how you calculate factorial with the function recursively. Oops. Like that. So I really encourage you guys to look up how to do recursive functions and how to do factorials because I'll explain this a little bit, but I think the ability to write recursive functions is a skill that you learn and through practice. And there is a method you can use to basically write recursive functions. But keep in mind that you can write factorials like this too. Let me show you this thing in action here. 10 dice, 6. So see how the result is 720 here?
Yes.
Calculate the factorial. The general principle behind a recursive loop is that, I'll draw this here in Paint using my Paint skills. You guys get to, this is a rare occasion. Like I don't use Paint all the time, but when I do, it's amazing. So imagine that you have this guy 10, and you want to calculate the factorial of this guy. So the way that a recursive function works is that, okay, you're going to say 10 is times some function x. And this function x is actually going to, you're going to pass in 10 times the function of 10 minus 1. Where the function, f of x, is equal to x times f of x. Man, my Photoshop skills are awful. I'm sorry about this. F, that's f. I swear that's an f. There we go. So the factorial, in this case, the function is equal to x times the function itself of x minus 1. Which means that as you're plugging in these numbers, you get 10 times this, which is equal to 9. Remember, that's what this is, 9. In this case, that's what I passed in, times the function of 9 minus 1, right? So a recursive function works by basically embedding a function within itself. The reason why it works is because not only do you have a function in itself, the key is this guy right here. Watch what happens when I don't have this guy in here. When I get rid of that if statement, I don't have an exit condition. Look, it even gives me a warning. I don't want to spoil the surprise here. Watch what's happening. So watch, look at this thing here. Do you guys see this? I'm scrolling, by the way.
It's doing that one line.
The infinite loop.
Yeah, it's an infinite loop. That's because I removed the ability of that function ever actually return a number. I didn't give it a way out. So what actually happened was that it basically ran out of memory on the stack. It didn't have the ability to store any more numbers anymore because I removed this guy here. This is the key. If you don't have this, it means that it can never exit because watch. This if statement says return a single number. This is the only case where we don't actually use the function within itself. Okay? So all recursive functions have to have a method of exiting. They have to have some way of returning out a result in addition to actually calling itself. It's a very common interview question, by the way. All right.
So if you use the recursive method, would you still be able to do the printout?
Sure. Oh, you mean the multiplication thing, right?
Yeah.
We start with this, right? And we get the little thing here, which again, you could put that down here now. Just put it at the bottom. Because we already have an if statement here that says if n is equal to 1, don't do anything.
Oh.
So now I have that times equal. And then the last thing I need to do is just print out. Oops.
But still seems ambiguous.
It's going to print out all the numbers, and then what we'll do is this thing right here, we're going to store it into a variable here. Like so. This is the other way that you can actually get it to print out all the numbers multiplied by one another. So I'm going to roll 10 dice, 7, and I can still do the multiplication equals that number. I just need to do it inside the function too. Let me show you that again. All you're doing is you're printing out the number, and then as long as you're not exiting out of the loop, print out the little multiplication sign here. This will mean that it'll print this multiplication sign out for every number except the last one, because the return here means exit early. Okay. I'm going to go over functions in more detail. I don't want you guys to get caught up yet. I have a whole lesson plan for how to do functions. So I more just wanted to showcase like some of the cool things you can do once you learn a little bit more about recursive functions. All right. Okay, so let's take a break and get back by 9:45, and then we'll finish off the lecture.